Hello everyone and welcome to the 4.3 notes proving triangles are congruent by SSS. So today's objectives are to determine if triangles are congruent using the SSS postulate and to prove triangles congruent using SSS. So what does SSS stand for? Well, it means side, side, side. So the previous section in 4.2 we learned that in order for triangles to be congruent they had to have 3 congruent angles and 3 congruent sides. Well, now we're minimizing that and we're saying as long as there's 3 sides of one triangle congruent to 3 sides of another triangle, then the triangles are in fact congruent. Alright, so for example, say I have these 2 triangles that I drew here in green. I'm going to label the first one, let's name it GO. So GEO. And then this one, let's name PHS. So say that GE is congruent to HP, EO is congruent to PS, and then GO congruent to HS. If I have the 3 sides of one triangle congruent to 3 sides of a second triangle, then automatically I would know that the triangles are congruent. I don't care if the angles are or aren't. I would just know, yes, they are, and then I would write my congruency statement, making sure that I'm very consistent with my corresponding. Alright, so let's look at examples 1 through 3. Decide whether the congruent statement is true. Explain your reasoning. So they're saying DFG is congruent to HJK. If I just look at these triangles, I see by the little tick marks that I have 1 on the bottom, 2 on the side, 3 are those like FG and JK. What I have to double check though is did they write the congruency statement in the correct order? Were they consistent with corresponding parts? So the first one goes D to F to G. So I would call that like a double tick to triple. Let's see if the second one follows that same pattern. Double to triple. So I would say yes. Side, side, side. Okay, SSS. The second one here, triangle ACB, is it congruent to CAD? When I look at these 2 triangles, the first thing that stands out to me is that these 2 sides are not the same. So the answer here would be no. And the reasoning would be the third side is not congruent. Or third side's not congruent. Okay, and this last one, just by glancing at it, appears that all the sides are congruent, the 3 sides. Let's see if the congruency statement is in the correct order. So Q to P to T is the way the first one is labeled, so double to triple. This one, R to S to T, double to triple, so yes, and the reason is side, 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 SSS. All right, this last example on this page is asking me if 2 triangles are congruent given their coordinates. I see right away that this coordinate plane is kind of useless, so I'm going to draw my own. All right, because I see that the second triangle that they want me to check goes through the point 10, and my grid here does not. So I'm going to do a triangle JKL in red. 1, 2, 3, 1, 2. That's J. 0, -2 is K, and then L is at -3, -8, 2, 3, 4, 5, 6, 7, 8. All right, so this kind of makes me happy because we have 2 segments here that I could count and see the length of them because they're horizontal vertical. So this segment right here, JK, is 3 units long. I could just count that. From J to L, I count that as well, and it's 6 units. Now off to the side, I'm going to find the length of LK because I'm going to check if these triangles are congruent. I need to know all 3 sides. So from L to K, it's 0 minus -3, which is going to be a +3 squared, plus, and then -2 minus -8 is going to be a +8 squared. I get the square root of 3 squared, so 9, plus 6 squared, so 36. This gives me the square root of 45. I will, of course, simplify this because we don't leave radicals not simplified. So square root of 45 is 9 and 5 are underneath there. Those are the factors of 45. So the square root of 9 times the square root of 5. Square root of 9 is just a weird way to write the number 3. So it's 3 square roots of 5. All right, so I have my 3 side lengths of triangle JEO. KL, they are 3, 6, 3 root 5. So now I'm going to see if triangle RST, which now I can't see what T is equal to. Okay, so RST, I'm going to check if this triangle is congruent to this one, to JKL. All right, so R is at 10, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's R. S is at 10, negative 3. And T is at 4, 0. So right there. Again, I see this triangle. I'm happy because I could count. I don't have to do the distance formula 3 times. So from R to S is a distance of 3. All right. From T to R is going to be a distance of 6. So far I know that it's possible that these two would be congruent by side, side, side. The last thing I have to do is find TS by using the distance formula. And so that's going to be 10 minus 4 squared, because it's x minus x, plus 0 minus negative 3 squared, so that's plus 3 squared, is going to equal the square root of 6 squared plus 3 squared. This gives me the square root of 36 plus 9. That is the square root of 45, which we just simplified over to the left in red. It's 3 root 5. So, graph the triangles and show that they are congruent. So I would say yes by side, side, side. Right, example 5, determine if triangle ABC is congruent to triangle DEF. I want you guys to pause the video and try this problem on your own. I will display the answer and be looking the answer only, and I'll be looking for work when I check in your notes tomorrow. Okay, so after graphing the triangles, you should have gotten that they are in fact congruent. By side, side, side. So we will be looking for your distance formulas. There were no horizontal or vertical links, so you did have to do the distance formula 3 times for each triangle. So make sure you have that work tomorrow. All right. Last thing here, we're going to determine if the congruency statement is true. So the first thing they told me is that triangle ABD is congruent to CDB. By reflexive property, I know that this side is congruent to itself, so they share a side. Those triangles are flat up next to each other. So the 3 sides are congruent. So now I just have to double check that the order that the congruency statement is in, that it's written in, makes sense. So the path for the first one, ABD, travels this way. So double to triple again. The path for this one is C to D to B, double to triple. So you would say yes, triangles congruent by side, 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 or something along those lines. Okay, next one, looking at it again, I do see that TR is congruent to TR. Those triangles share that side. So the 3 sides I see by the tick marks, they are in fact congruent. Let's see if the congruency statement is written in the correct order. So R to S to T, double tick to single, T to Q to R, single to double. So this is no. The triangles are, you would write the first one, whatever order you want. Let's say I wrote RST the way they did. RST is congruent to, I would have to take that same path, and instead of going single to double, you go double, single. So it's congruent to triangle RQT. All right, that is it for this section, 4.3, side, side, side. Make sure the 3 sides of one triangle are congruent to another, and then you have to double check that if you are given a congruency statement, that it's written in the correct order of corresponding parts, and likewise, make sure you know how to write it in correct order. All right, thank you so much for watching. Have a great day. Bye.